first one, and I told you to do it out the long way. Some of you probably realized as you were doing it that it felt kind of stupid, but we'll do it anyway. So I'm going to start on the inside, and I'm going to do the antiderivative of 3t minus 2. What is the antiderivative of 3t minus 2? 3 over 2t squared minus 2t. I'm going to evaluate that from 1 to x. What is a definite integral evaluated from 1 to x? 3 over 2x squared minus 2x minus 3 over 2 minus 2. Right? For whatever crazy reason I would want to do that. And then I'm going to do the derivative of that. What's the derivative of 3 over 2x squared? 3x minus 2. What's the derivative of this stuff? Why? It's constant. So you tell me why that was a big old waste of my time. Isn't it the exact same thing that's up there? Today we are revisiting the first fundamental theorem of calculus. I mentioned it the first day and said, hey, we're going to need to work on this a little bit more and how we can apply it. The first day we were just learning that antiderivatives and derivatives undo each other, which was good to note. But the fundamental theorem, if you will, glance back in your notes at the first fundamental theorem of calculus. It says the derivative of the integral from a to x, a being a constant, so this one was 1, but a to x of f of t dt is just f of x. And remember the first day how some of you were like, why did the variable change to x? Y'all remember that? Why did the variable change to x? Yeah, the definite integral, I plugged in the x, right? So that's why the variable changed. Some of you were like, why would it do that? Well, now you can see work-wise why it does that. But we did learn that, hey, I don't ever want to do that again. That's a big waste of my time. Everyone agree with that? So let's look at the next two. They may not be quite as much of a waste of our time, because do they look exactly like the theorem? What's different on number 2 than the theorem? It's x squared instead of x. So I do need to figure out how that's going to affect my answer. So I'm going to actually work it out the long way. And then hopefully figure out a good shortcut, because we like shortcuts. Math people are lazy if you haven't figured that out yet. Any questions so far? I am going to do this derivative probably slightly differently than you normally would. I'm not going to simplify it algebraically. I'm just going to do a chain rule because I'm going to show you a shortcut later. So I'm going to do the derivative and use a chain rule. 3 over 2 times 2 gives me 3. Leave the inside alone to the first power. Everyone agree with that? Times the derivative of the inside, which is 2x, minus 2 times the derivative of the inside, which is 2x. If I did some factoring, wouldn't that be 2x times 3x squared minus 2? Everyone see that? Well, why would I want to write it that way? This is that top-hand limit plugged in to 3t minus 2 times a chain rule, because it wasn't just an x. So you can see how we're going to do that much shorter next time. Last one. I want to see how this affects it. Some of you probably know the answer. How does it affect it if these are backwards? It's going to be negative. We'll verify that, but let's try it. Go take the derivative. What happens to all the constants? Go away, and then I get negative 3x minus 2. I'm actually going to rewrite this a little bit differently, but we'll start with the basic fundamental theorem of calculus part 1. So we're revisiting the fundamental theorem of calculus, which said let f of t be continuous on the closed interval a to b, then if g of x is the integral from a to x of f of t dt, then g prime of x is f of x. That is the first fundamental theorem of calculus. Now, I am going to do a more general format. Still f of t being continuous on AB, as you know, that has to happen for me to be able to do a definite integral. But then this time, if g of x is the integral from a to u, where u is some function of x, it has to be or it wouldn't be g of x. That allows us to work with things like x squared. Do you know what I'm talking about? Yeah. Then, g prime of x is f of u times u prime. Chain rule, right? Makes sense from the second problem we did. You will want to use this general format. In fact, you'll notice your last question on that mastery exam that I just gave you. Look at it. See what kind of question it is? It's this question. Anyway, so that's what we're going to work with today. Not a too difficult day. Okay, so let's look at the first one. I have the integral from 7 to x of 2t minus 3 dt. That is called capital F. When we have a capital F, what's a lowercase f mean? The capital F is the antiderivative, right? So what would lowercase f be in relation to its antiderivative? Its derivative. So the derivative of this is what? 2x minus 3. No work. Let me use a different color so that doesn't look like part of that theorem. 2x minus 3. No work expected. We're just going to use the theorem. I hope on the AP exam you are not working that out. I hope you plug it in. Because that's what the first fundamental theorem of calculus says, that the derivative and the antiderivative undo each other. At first glance, this looks like a very complicated problem, doesn't it? In fact, I can't even think of a U to make this where I could do this problem. I can't find that antiderivative. I do not know how. And I don't care. Because what's it asking me to find? The derivative of that. Well, what is the derivative of it? Why negative? Negative sine of z over z? Where's the z coming from? That's the variable we're using here, right? Now, if it were anything other than z, be careful. Speaking of, let's try one like that. This, because what's the derivative of the integral? Just the original, right? Now, why is it negative? Because the z's on the bottom. It's the wrong way for the theorem. So we're going to pull a limit switch and put that to where it is like the theorem. Does that make sense?
So what you can do is if you have like a variable something.
Yes, if you have a variable on the one of the two limits. If you have a variable on both, you will on one of your homework problems tonight. You may have to work it out the long way, but then think about what it would do. So that'll be your challenge question.
Like it says, if big F to Z or to X or anything, the F of X is like then the F of X and the F, like the big F derivative of X is the exact same thing.
As,
like
yes.
Those two things are the exact same thing.
Yes, these are the same question, except this should be a Z. That's a typo. Yeah, the big F and F prime is the same thing as big F and little f. That little f is the derivative of big F. I don't know. Do I need to take a derivative or an antiderivative? It is the derivative, but I have a derivative of an integral. What's that mean? The derivative and integral do what? They cancel. So what is this answer? Y times 2x. The chain rule. Because remember the long way, and I'm going to go back to remind you why that happened. Now, we're not going to do it the long way because I don't want to. In fact, would you agree the antiderivative of cosine of x squared would be something you can't do anyway? It would be a problem. Or was it? Wait, it might have been plain cosine of... You might can do it. Anyway. But the reason this happened is when I do that derivative, because this is something other than just an x, I'm going to get a chain. But
If we do the cosine of x squared, we do
you can't. You mean an antiderivative?
No, just the derivative. Like
A chain rule.
So it would just be 2 cosines.
It'd be, so if you were doing the derivative of cosine of x squared, which we're not, but if you were, it would be negative sine of x squared times 2x. Antiderivative, however, would be impossible at this point because you can't do a u substitution because you don't have an x sitting out front. And you don't have a chain rule for integrals, so it would be impossible. Okay, any questions about this one? That is the revisit of the fundamental theorem. We're going to do some AP problems now. We are almost to the end of this chapter where we're just reviewing. We have one more tiny little topic to cover tomorrow. So, because the fundamental theorem revisited is a pretty short lesson, it's time to start looking at some AP problems. So look at this first one. See if you can get anywhere on it. Okay, so it says let h of x be the integral from 0 to x of f of t dt. The graph of f of t is what's shown. So h of x is not the graph, it's f of t that's shown. At what point will h of x have the greatest value? Well, first I need to decide what am I looking at in relation to h. What is f of t in relation to h? H prime. Does everyone agree with that? F of t is h prime. How do you know? Antiderivative of that thing, so that thing must be the derivative of h. Now, if I have a derivative, how do I find a maximum from the derivative graph? Okay, I look at where it equals 0, which I actually have two places where it equals 0.
Or positive, negative.
Why positive to negative? Because I want to find a maximum. What would a negative to positive change be? It would be a minimum. So the greatest value would happen at, is that B? I circled it and got it where I can see it. Greatest value would happen at B. Does that make sense? Any questions about that? So, is this a question I've asked you before? Sort of. But this time it's integral defined instead of derivative defined. So you'll notice that a lot of the AP problems we're going to be asking are going to look very similar, except have a little bit different context with an integral now instead of just a derivative. Same question almost, except minimum. So I mean it's a different graph, but same question type. So you can tell this is common AP question. Let h of x be the integral from 0 to x of f of t dt, where the graph of f of t is shown in the figure below. At what point will h of x reach its minimum value? So don't say anything. Everyone get an answer. Let's try. Don't say it out loud yet. Does everyone have an answer? Not yet. Okay, you got to vote for something. How many of you vote A is the answer? How many of you vote B is the answer? C? D? E? Okay, why C? We're changing, so I want a minimum value, right? And we decided that h prime is f. This is the graph of f. So this is the derivative graph. To find a minimum, the derivative would need to change from negative to positive. Everyone agree with that? So that does fall at point C.
Maximum, or not maximum?
We would have had to have,
Absolute minimum?
we can't tell from this graph, sort of. We'll have to talk about that a little bit more. Absolute's got a little bit more to it than we would have to look at the accumulation of area and make an estimate on which one accumulated more area. It would have to have endpoints for that to happen, and it would be a different. Okay, I'm going to work number 1 with you from your AP packet. Your homework, oh, I said 1 through 4, I lied. Your homework is AP packet 4 through 8. And then page 306, 2 through 18 even. AP packet 4 through 8, 2 through 18 even. Today and tomorrow and over the next few days, I'm going to work numbers 1 through 4 with you. So that means you will only have 4 through 16 to work on your AP packet. So I'm going to work 1 through 3 with you. Okay, number 1. So we've got some things to learn about these integral defined functions. Do up. Oh, sorry, I can go back.
306.
306, 2 through 18 even.
This is all that you do tomorrow.
The 2 through 18 even, and then try to get most of the 4 through 8 done, but we'll take the 4 through 8 up on Monday. But you will have new homework tomorrow, although it's not a ton of new homework. What was that, 4 problems on the front of that worksheet, plus a book page that was 5 problems, so 9 total? Does that look right? About 9, maybe 10. 8 maybe? So we're talking minimal addition tomorrow. So 4 through 8 will be the lengthy part of your homework. As you know, AP problems can take a little bit. But we will work 1 through 3 together. Okay, number 1. The graph of a differentiable function f on the closed interval 1 to 7 is shown above. Let h of x be the integral from 1 to x of f of t dt for 1 to 7. Find h of 1. Now, at first glance, that looks like something I can't do because I don't have a function. I can't find area. I could estimate with a Riemann sum or something. Why is it doable?
1 to 1.
It's the integral from 1 to 1. Right. So isn't this the integral from 1 to 1 of f of t dt? I don't care what f is. That integral 0 because the integral, if I don't go anywhere, I don't accumulate any area. So it looked like an impossible question at first glance. And it turned out not so terrible. Any questions about that? Find h prime of 4. Why is it just 2? Because h prime is f. So if I want h prime at a point, it'll just be the y value. I'm leaving the AP reader no doubt as to where I got that answer, especially if you feel like the graph is hard to read. Do you know what I mean by that? If you're having a hard time telling if it's 2 or 2.5, or show the AP reader where you got it. You may pick up the points even if they thought you were wrong. If they see that you knew what you were doing, it can help you pick up points. Now, it didn't say justify, so I don't have to use any words. But always show your work because you can pick up partial points that way a lot. On what interval or intervals of the graph of is the graph of h concave upward? Justify. Ooh. I gotta know what I'm looking at. What's this the graph of? F, which is h prime. Does everyone agree? So what do I need to look at for concavity? H double prime, which is what on this graph? The slope, right? The derivative, which is the slope. So if I want to know when I'm concave upward, so for the AP reader, I'm going to tell them what I just thought about. F is h prime. I'm going to tell them I know that. F is oops, sorry, not F prime. You could say F prime. I'm going to say F is increasing. Now, what's another way I could say that and be completely and absolutely right? I could say F prime is positive, right? So I'm going to say F is increasing, or you could say H prime. You've labeled that you know that's the exact same thing, so it doesn't matter which word you use there. From 1 to 3, and from 6 to 7. All right. Therefore, h is concave up on those intervals. Now, is that the only way I could word that? No. Do you have to hit all the same things in your wording? Yes, you could say f prime is positive instead of saying f is increasing. You've got some leeway in the way it's worded, but the answer has to essentially be the same thing. Any questions about that? Does this feel like something we've done already? The only difference is now we've got an integral defined function instead of a derivative defined function. Okay, let's look at D. Find the value of x. So this is Grant's question. We're going to tackle Grant's question. At which h has its minimum. If it doesn't say relative and it says its minimum, what does that seem to allude to? Absolute minimum. On the closed interval 1 to 7, justify your answer. Well, let's go look. Where are our possibilities for a minimum? 5, 7, and 1. Why 5, 7, and 1? Good. Remember, we're going to do a candidates test. For an absolute minimum, it could occur at a critical point or it could occur at an end point. Everyone agree with that? 5 is a relative maximum. So is it a minimum? No. Either means my minimum's at 1 or 7, done. Right? Gotta be. So from 1, my derivative is positive. Right? What does it mean if my derivative is positive? Increasing, right? So from 1, I increase, 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 increase. How much do I increase? Whatever this area is. Does everyone agree with that? Because I could find displacement by finding that area. And then I decrease this little bit. From 1 to 7, did I increase more or decrease more? Increase more. So which one's lower? 1, because I increased more than I decreased. I went up, 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 and then down a little bit. Does everyone see that? So, now I need to talk about AP Reader. What does the AP Reader need to know? So we use a candidates test. F of, what did it ask? What x values? Find the value of x. Right, you could say that several ways. F of 1, F of 5, and F of 7 are candidates for minimum. You could even get away without even listing the F of 5. AP knows you threw it out, but I'm going to go ahead and say it. F of 5 is a relative max. So I'm telling the AP Reader I'm throwing that out. From x equals 1 to x equals 7, h increases. Oops, there's an N in increases. Increases more than it decreases. I used a no-no word. Was it okay? I used it. Normally I just mark that out and say don't do that. Is it okay that I used it? I already stated I use it. Remember, make sure you use an antecedent before any pronouns. Talk about a little bit English in here. Just be careful about that. Don't say it increases. Why not? It could be F, it could be H, it could be anything. Make sure that you specify that. Of course, this is not the only wording. It is good wording. It is not the only way you could say that. Do you notice that I just put down on paper what went through my head? Yep. It's probably not a bad idea. Therefore, x equals 1 is where h has a minimum. Yeah, you're right. I needed to answer the question. I never did. Normally I do it at the beginning. I don't know where I was going with that.
So why is it not 7 again?
Because I increased, remember this is the derivative, right? So from x equals 1, I increase this whole area amount. So whatever that area is, that's how much h went up. I don't know what it is, but I know that's how much h went up. This is how much h went down. So from x equals 1, I went up, and then I went down. Wouldn't you agree the minimum would be there because I didn't go down as much as I went up? I could find out exactly how much if I had a function and could do the integral, but I don't. So the next one, we actually will be able to find some areas. Why on this one can we actually find areas?
It's not a straight line, like a continuous thingy. Or not continuous, but like.
Not curved.
Yeah.
Yeah, it's straight. It's geometric. We can find shapes and areas. So very similar question, slightly different. Compute g of 4 and g of negative 2. Now at first glance that looks like it would be difficult since I don't have a function. But what is g of 4? The integral from 1 to 4 of f of t dt.
So we wouldn't do it first. We wouldn't like do that thing like if it gave us like g prime, we do our substitution first.
Right. So if it were g prime, then I'd just find f of 4, which would be negative 1, be done. Which it often asks that question. But how do I do this one? We did this on like the second day of integrals. It's been a while. How do I do that? Say that again. Riemann sums if I must. On this one, I'm just going to do geometric area. So I'm going from 1, 4. Can't I break that up into a trapezoid and 2 triangles?
The 2 triangles cancel.
The 2 triangles cancel. That saved me a lot of time, didn't it? So I only need the 1/2 4 plus 2 times 1. What formula am I using there? Trapezoid. If you wanted to break it up into a triangle or rectangle, you can do it however you want. Now, it's good for you to know the area of a trapezoid formula, but you can do it however you want. They don't care. 8 divided by 2 is 4. This probably would be a non-calculator. Oh, thank you, Grant. Which brings me to my next point that I was going to mention. I would like to pretend I did that on purpose, but I didn't. This is probably going to be a non-calculator question, and you do need to know that on a real AP exam, if you stop there, you will get full points for that part. If you say 4 plus 2 is 8 and write 4 down, you'll miss the answer point. So there is a very good argument for not writing equals 3. I'm going to do it for now just because practice for multiple choice as well. But at some point you're going to start practicing for AP not simplifying things like that, just for safety purposes, because you might add 4 and 2 together and get 8. It almost seems like I did that on purpose, doesn't it? I didn't. Okay, g of negative 2. What's weird about that? It's backwards. Okay, so I would probably immediately rewrite that. I'm showing the AP reader that I know what I'm doing. yes, you would get the points without showing that extra step as long as you put a negative in front. So I'm going from 1 to -2, but I'm going to switch it to go from -2 to 1 and then just put a negative in front. That's a triangle. Everyone agree? So I get 1/2 base times height. The base is 1, 2, 3 units. The height is 4 units. Does everyone see where I'm getting that? It is negative because I went backwards. -6. Again, you could leave it as 1/2 times 3 times 4 if you felt like it. Okay, any questions about that one? Find the instantaneous rate of change of g with respect to x at x equals 1. Don't you love AP and their ways they throw things at you? What do you need to know about instantaneous rate of change? That's the derivative. So aren't they really asking you to find g prime of 1? It'd be nice if they just said that, but they didn't. Well, what is g prime of 1? What'd you say?
4.
Why is it 4? F of 1. Do you agree with that? The derivative of g is just f, which is 4. I agree. Now, you tell me Hunter said does not exist at first glance. What doesn't exist? Because there's something that doesn't exist. G double prime. Does everyone agree? G double prime of 1 does not exist, which would be the derivative of f. He was looking at that, right, he was looking at that sharp corner. Isn't that what made you say D and E at first glance? And so at 1, the thing that doesn't exist is G double prime, which may be a question next time. You may be asked to find G double prime, and because of that sharp corner, it doesn't exist. G double prime anywhere else would be the slopes of those lines, which you could find. Good question, or good, you brought up a good question with that answer. Find the absolute minimum value from -2 to 4. What it doesn't ask is it doesn't ask us to find the x value. It actually wants absolute minimum value. So I need y value. That could be tricky. Justify. Well, what are my options? I'm going to erase some things on this picture so we can see what's going on. What are my options? -2, 3, and 4. Is 3 truly an option? Why not? It's a relative maximum, right? Everyone agree with that? So G of 2 and G of 4 are my only options. Now, on the last one, I just had to speculate, which made my justification a little trickier. Can I find G of 2 and can I find G of 4? Oh, sorry, -2. Didn't I already do that? No. This is where I do need to go ahead and find the number answers. You remember I said on part A I could have left it. Well, on part D, or part C, I'm going to have to go ahead and find those numbers because I'm looking for whichever one is smaller. And just for your work purposes, you might go, what was that other one? G of 3. Uh-oh, you're right. Man, that's like twice in one day. God, y'all are on top of things. G of -2 is -6, and this is 3. And then you might go ahead and mention G of 3. I'm not even going to find it because I don't need to. I'm just going to say relative max. That way the reader knows I thought about it. Yeah, I eliminated it.
Will they ever like look at the pictures and be like, oh yeah, that's cute?
No. They will not grade pictures. They won't grade sign charts. So you do have to put it in words. So, this is truly a candidate's test. -6 is smaller than 3, right? Therefore, -6 is absolute minimum on -2 to 4 by candidates test. And notice it said minimum value, so that's why I answered with -6 and not with -2. Good. You can say that. You see why I made you say that early on? You have both, and you covered your basis. If you said the absolute minimum is -6 at x equals 2, so you remember how I made you word it that way, and you were probably like, why'd you make me do that? Because that's stupid, I could just write a point. I was practicing you for this skill so that you knew which one was which, and if you said it like that, you covered both answers. You covered the x value and the y value, and you can't mess it up that way. Part D. The second derivative of g is not defined at 1 and 2. So, Hunter, that was our discussion earlier. They're not leaving anything up to, they're saying it's not defined at 1 and 2. How many of those x coordinates are points of inflection? They may ask this question without even telling you that. They may just say, what are the points of inflection? They did give you a big hint, and one of the biggest mistakes you make with points of inflection is forgetting the part that we have to justify here. What constitutes a point of inflection? 0 does not exist on a second derivative and a sign change, right? That's the part you always forget, is and the sign change. They kind of left that to where you had to think about it on this one. So would you agree 2 is not a point of inflection because I'm decreasing and then decreasing again? But x equals 1 is a point of inflection. And your justification on that is because g double prime changes from positive to negative, or you could say g prime changes from increasing to decreasing at 1. And you would say at 2, g prime does not change from increasing to decreasing, or vice versa, or you could say it stays decreasing. You got some options. I don't have time to write that justification today because the bell's about to ring. But how do we feel about today's stuff? So we revisited fundamental theorem and did some AP problems. 4 through 8 are due Monday. Those other, 9 problems due tomorrow.